Hello everybody, now I will be explaining solutions to Codeforces round 662. So let's start with problem A. Well, in this problem, you can just try to solve examples for different n just by hand, and then you can just figure out that you can just find a pattern and see that answer is always n divided by 2 plus 1. Yeah, so this problem is kind of easy, not that hard. Okay, let's go to problem B. Yeah. So problem B is quite, I will call this problem implementation problem. So here you just need to, I guess, implement what problem asks, but maybe this problem is quite tricky. Yeah, so let's figure out when answer is yes. So answer is yes when we can make a rectangle and a square as well. So in order to make a square, we need to have we need to have a plank. We need to have a plank with occurrences at least 4. Yeah, so number of occurrences has to be at least 4 in order to make a plank. Sorry, square. Yeah. Yeah, so if we have, let's say if we have 2 planks with occurrences at least 4, with number of occurrences at least 4, then answer is for sure yes, because we can just make 2 squares. That is fine as well. Well, in order to maintain such information, I guess, I think you can just store map for to store number of occurrences for each plank, and maybe you can use set to store all planks with at least 4, for example 4 number of occurrences. Well, yeah, so if you have if you can make at least 2 squares, let's say at least let's say if you can make at least 2 squares, then answer for sure is yes. Well, if you can't make a square, then the answer is no. And now let's try to solve the last test case when when you can make only 1 square. Yeah, if you can make only 1 square, then what you should do in this case? In this case, you need to count. So if you have if you can make only 1 square, you should consider how many rectangles you can do, like you can make. Yeah, for example, if you can make, let's say if you can make at least so if you can make only 1 rectangle, so let's suppose we have so let's suppose we have such length of planks. Let it be like 4 ones, and so from these 4 ones we will make 1 square, for example. And let's say that we have 2 different planks with 2 different lengths with occurrences at least 2. Well, in this case, we can make a rectangle, so it's fine. The answer is yes. Yeah, so this problem is kind of when you need to consider many cases. But yeah, So if you have two different lengths with occurrences at least 2 for each length, then yeah, then you can make a rectangle for sure. You can also maintain a set for planks with occurrences at least 2. Well, yeah, well, now let's consider another case when you have only one length with occurrences at least 2. Sorry, yeah, with at least 2. Then sometimes it's also possible to make a rectangle and square. For example, if you had 6 ones, so from these 6 ones you can make one square and one rectangle. You also just need to check such case. So this problem kind of has many corner cases. So just accurately check them. I mean, carefully check them, and yeah, that's it actually. Well, now let's go to problem C. Well, this is actually a really interesting problem. And as an advice, whenever you ask it to minimize something or maximize something, always try to think of a binary search. Well, yeah, so let's try to use binary search in this problem. Yeah, so in this problem, like whenever we eat a cake, yeah, so let's just consider this example. Yeah. So let's just a bit change this array. So let's just write number of occurrences for each cake, for each type of cake. For example, we have cake of type 1, 4, 6, and 7. Yeah, and number of occurrences for each cake is, so we have 2 cakes of type 1, we have 2 cakes of type 4, and by 1 cake of other types. So whenever we eat a cake, we just decrease like these numbers, one of these numbers by 1. So for example, when we eat cake 1, so number of occurrences just is decreased by 1. Yeah. Well, yeah, so we want, yeah, so if you want to, yeah, let's just reformulate the problem. Let's just change the problem. So let's say that we want to make all number of occurrences equal to 0, but we can't take, let's say, the same cake like more than like some number of times. I mean, like because here we also have a distance or something like that. Yeah, like distance between 2 cakes of the same type. So yeah, so let's suppose that we do a binary search, and let's say that we want to check if we can find the correct ordering. If we will, if the maximum distance, yeah, if the maximum distance will be at least, let's say, x. Yeah, so then we wouldn't be able to eat the same cake if the distance to the previous cake of the same type is less than x. Okay, I think that makes sense. Yeah, so let's suppose we are doing binary search and we want to check if answer can be at least x or not. Okay, Yeah, so let's suppose we are checking, we are doing that. So for example, for this test case, answer is 3. Well, yeah, so since on each step we just decrease one of these numbers by 1, and we want to have at the end like an array with zeros. So if you so from the first side, it seems that we should do this problem, like we should solve this problem like greedily. Like on each step we should pick a cake with the biggest number, like with the biggest number, yeah, of occurrences. And actually, yeah, this is optimal strategy. So let's just simulate this process and check if we can finish this process or not. So if we wouldn't be able to finish, then it means that answer is less than x. Yeah, otherwise it's at least x. So yeah, so by this check, for sure we can do binary search. So let's just try to simulate this process. Yeah, on each step we will be just choosing a cake with biggest number of occurrences. Yeah, so for example, let's say that we choose 1. Yeah, so let's suppose, yeah, by the way, let's suppose that we want to check answer. Let it be x equal to 3, for example. Yeah. So yeah, we just choose any cake with the biggest number. So let's say it will be 1. Yeah. After that, we decrease this number of occurrences by 1, so it will be 1. Then we choose 4. And we choose 4. And now we can choose any of case because they all have the same number of occurrences. However, we can choose 1 because if we will use 1 here, so the distance between the same cakes will be less than 3. Yeah, so sometimes we should ban some cakes. Yeah, and let's say that for now, cake number 1 is banned because if you take the distance between cakes will become less than x. So in that case, we can choose any of the remaining cakes. So let's say, yeah, 4 is also banned because we just took it here. Yeah, so now we can choose any of remaining ones. So let it be 6. Yeah, so now we can't take 6 anymore. Okay, then we can take only 7. Okay, so then yeah, so we make this number equal to 0. Okay, and now as you can see, we can now because distance became 3, so which means that actually we can unban cake number 1. Yeah, but we still can't take cake number 4. So then we just take cake number 1. Yeah, and then we unban cake number 4 and so on. And finally, we complete this simulation. So, and as you can see here, we took all cakes like successfully and everything was fine. So yeah, actually you just need to simulate this process and check if you can complete this process or not. And yeah, so for each x you'll be just doing this process. Yeah, x you'll be finding x by using binary search, like our answer, let's say. And if you wonder how you can simulate this process, well, if we didn't need to ban some cakes, then for sure we could use maybe like a data structure as a set or map to every time pick cake with the biggest number of occurrences. However, uh, we here sometimes ban cakes, some cakes. Well, we also can, yeah, we also still can use a set or map in this problem. For example, with map we can count number of occurrences for each cake and then just process this algorithm. And yeah, and use a set to maintain all these operations. Yeah, so for example, if you wonder how you, like, if you still don't understand how you can do that, well, you can have a set. Let's say you'll have a set or like of pairs. The first value will be number of occurrences, and second value will be just the type of that cake. And each time you will just pick a cake with the biggest first value. So this is just like last value of that set. So for example, if you're iterating through from left to right, and yeah, and let's say that you're currently at position I. So yeah, at this position, you just choose last element as set. Then you ban this number or this type of cake. So which means that you should delete that item from the set, and you also need to decrease number of number of occurrences by 1 in your map. And sometimes if there is element on position I minus x, which means that like if there is such element, this means that like on next step this element will be available, because like for now all these elements were banned, but from the next step element cake of type 1 will be available. So which means that you should add this element to set. Yeah, whenever like, yeah, for example, if you're persisting, if you're just doing this like algorithm, and if somehow your set became empty and you can't choose any cake, that means that there is no answer, there is no correct ordering for a current x, for a current distance. Yeah, that's actually it. So maybe you wonder, wouldn't be that slow or not? Actually, that wouldn't be slow, because here time complexity is n log square, because you do one search, that's log of n, and because you're using sets, that adds extra log, so that will be log square. Yeah, that's fine. Okay, and problem D. Yeah, so this actually is a very interesting problem. Very interesting problem. So here, in this problem, let's just try to figure out how we can find like a largest rhombus with a certain center. Well, yeah, let me just copy maybe this picture. Well, well, this problem constrains n and m up to 2000. So here you can just do brute force to find largest rhombus for each center. Yeah, so normally such problems you should do either binary search or dynamic programming. So yeah, so let's try to solve this problem with dynamic programming. So for example, here we see that we have a rhombus of length 3. Yeah, like all cells within distance of 3, within distance 3. Yeah, or that's okay. Yeah, let's. I think that's rhombus of size 2, of length 2. All cells within distance of 2. Okay. Anyway. So actually, we can kind of decompose this problem into 4 parts, like this rhombus into 4 parts. So for example, we can. So like rhombus exists, for example, of length 2. I mean, you can think of this rhombus um, as four such I guess. Oops. As 4 such shapes. So this is like a stair, and there is like another stair of length 3. And yeah, there is another length stair of length 3 as well that goes down and left. And the last one to the right. So actually, if you could, find, like for each side, the maximum length of a such, let's say, stair, then answer will be like the length, or the length of, like maximum length of a rhombus at this center will be just minimum length of all stairs. Yeah, of all 4 sides. Yeah. So from now, let's just try to come up, figure out how we can calculate such lengths, maximum lengths of stairs. Yeah. Since here we have 4 sides, let's just simply try to do that for one side, and for other sides we will do the same logic. We will apply the same logic. So for example, here if you have a stair of, let's say, length 3, then actually here we should have a stair of length at least 2, and here we should have a stair of length at least 2. Which means that if you do dp, so answer for if your center is here, let's say if your center is in position I, j, then answer will be just like the length of a stair that ends at position I, j will be minimum length of that stair, which is dpi j minus 1. And the length of this stair. So that should be dpi minus 1j. Yeah, so if you here have a stair of length 2 and here you have length, sorry, stair of length 2, then current stair will be of length 3. Yeah, so thus you shall add +1. And the reason why I do minimum is because, yeah, let me just show an example maybe. Let's say here you have a, yeah, let's say that this is your center, but here you have a stair of length 3. But here you have a stair only of length 2. Sorry, here you have a stair of only of length 2. Yeah, thus your stair that ends at this position will be just of length 3, not 4. Yeah, thus you take minimum. Well, by simply computing such GP for each side, then the length of rhombus, the maximum length of rhombus that where the center is position I, j will be just minimum value among all lengths. Among lengths of all 4 stairs that ends at this position. Yeah, so that's thus the time complexity of this solution will be just n times m, because for each side you compute dp in of an m time. Yeah, that's actually it. That's problem which I like really. Kind of interesting problem. Non-standard maybe, I would say. But maybe this problem is standard. However, not that simple, which simple as problems with as not problems for dp on matrix or yeah on grids. Yeah, actually, I think that's it. So thank you for watching. I hope you learned something new. Please do subscribe to this channel, like this video below. If you have questions, you can ask them below. So good luck. See you in the next video. Bye bye.